The notation of this question is a little distracting because the vertical bars look like the symbols to indicate absolute value, but in fact, they indicate something else. No matter, we will keep the definition in mind. We want to know whether n in bars equals 0 according to the definition. And applying the definition, that means we want to know whether 0 is the largest integer less than or equal to n. If 0 is less than n, then n is positive. And if 0 is the largest one, less than or equal to n, that means, for example, that 1 is not less than or equal to n. So we want to know whether n is greater than or equal to 0 and less than 1. In other words, this expression. Working with this expression will be simpler. Let's turn to the data statements separately first. Statement 1 tells us if we multiply it across by 2, the following expression, which we can reorder and learn that n is between -1 and +1. From here we can analyze by cases. In one possible case, n is 0.5. That's allowed by data statement 1, and in that case, the answer to our question is yes, it's true that n is between 0 and 1. In another possible case, n is -0.5. That's allowed by data statement 1, but in this case, the answer to our question is no. Therefore, we have insufficient information to answer the question definitively. Statement 1 is insufficient. Statement 2 tells us that n is negative. What does that mean? We can consider a case. N could be -0.5, as we just discussed for statement 1. That case yields a no. It could be a number such as -10, which also yields a no. We notice that in any case allowed by statement 2, the answer to the question will be no. Therefore, we do have sufficient information to answer the question definitively. Statement 2 is sufficient, and the correct answer is B.